Let's work on the script 8a. We are now ready to detect water using an index. Let me run the script. The script takes an admin region, computes various indices, NDWI, MNDWI, AV, and we visualize this. Let me zoom into one particular region so we can kind of see the results of our work and compare. So let me just go to this particular water body. So this is a water body. Let's say we want to detect all the water in this image, and I want to just kind of separate the water versus non-water. We can use this index. We have this MNDWI. You can kind of see the water in blue, but again, this is a continuous image. If I inspect the values, if I inspect it somewhere here, you'll see that this is negative 0.26. As I come close to the water body, you'll see it's kind of a negative one. As I come in the water body, you can see this is 0.3. So I had to figure out at what point this image transitioned from being not water to water, and then I can detect the water pixels. So let's say I want to detect water from this NDWI. We can say I have this MNDWI image. I want to apply and condition saying that any pixel greater than certain value is water, lower than that is not water. The conditional operators take the form of this. They are EQ for equal, GT for greater, LT for less than, GTE for greater than equal to, and so on. So if I say this condition will run against each pixel of this image and say if the pixel is greater than 0, the output will be 1. If the pixel is not greater than 0, the output will be 0. So I'll get a binary image as the result of this particular operation. Let's visualize this one. So I will now visualize water, MNDWI. I need a Viz params, so I will define a water Viz. Here, the values are just 0 and 1. There are only two values in the image. We turned a continuous image into a Boolean image. And we can visualize it like this. So Boolean operators feel a lot like filters, and it's also very confusing when you are just learning Earth Engine, that when to use filters and when to use this Boolean operators. When you are working with images, you have to use this Boolean and conditional operators. When you're working with image collections and you want to select the images, that's where you use the filters. So you can see now I have this image, which is a zeros and ones. If I inspect it in the water, you'll see that this is 1. If I inspect it in somewhere outside the water, you'll see that this is 0. So where the condition matched, it was 1. Where it didn't match, it was 0. And you can see we got a pretty decent boundary of the water detected from the image here. And outside the water edge, it's not water. But again, it's a lot of noise. One problem with this MNDWI is that you need to figure out the right threshold. Is it 0? Is it 0.1? Depending on the region. We can try different threshold. Let's try like 0.1 and see what the image looks like. You can see this looks much cleaner, but again, this may not be the right threshold. So again, it takes some trial and error to get the right threshold that gives you a clean image. You also have to post-process this image a bit to remove this isolated pixels and so on. So, but it's a pretty simple and straightforward approach. If you're just working for a region and you just say, I want to extract water, I'm willing to play with it for a few minutes and find the right threshold, that's fine. You can do this approach and you'll have your water bodies extracted. If you're working in a larger region or a time series, then you may want to say, I want a more robust automated approach. In that case, let's use the AV here. And we say we have this AV. Here, the promise of AV is that there'll be a stable threshold of 0 for water. So let's see if that works out. So I'm going to create this new image, water AV, where we'll take the AV image, which is our index. We'll say greater than 0 is water. Let's compare that. And now we have the image. We'll compute the AV. We'll apply this condition that anything greater than 0 is water. So what you see right now is the condition on MNDWI, and now what's being computed is the condition on AV. So this is the result of our AV threshold greater than 0. This is our M into WI. You can see this is much cleaner, right? It kind of AV lives up to its promise that you can have a stable threshold and you can detect water much easily. So this looks definitely better. But again, depending on the region, you can see some of the regions here, there is, AV sometimes tend to miss whatever is, there are water at the edges of the water body that sometimes AV tends to miss. So if your water is not very pure, it's with vegetation, AV is not, sometimes misses more water pixels. So again, you have to try it for a region and see what works for a region and select the appropriate index. One more thing that you can try, and this is true for a lot of reservoirs, especially in India, a lot of the reservoirs here do not have pure water. When you try to do this thresholding, you'll see that you miss large parts of the reservoir because they have vegetation growing there. There's lots of sediments, there's a lot of vegetation. So you can combine two indices and compute the results together. So let's do combine two indices. So we'll say my water detection algorithm is a little more sophisticated. We'll say water is where M NDWI is greater than 0 and NDVI is less than 0. Like I want to combine these two conditions. And only when these two conditions are met, I want to consider that as water. So let's see how we can implement this. So we'll name this variable water multiple. We'll say M NDWI greater than 0. We have another condition where we say NDVI is less than 0. And I want to say I want to combine them using the AND operator. So now I can do this. So these are the conditional operators, GT and LT, and then AND and OR are the Boolean operators. So we combine this, and now only the pixels where both these conditions match will be shown here. Let's load the results and see how the result looks. So this is the result of our thresholding AV, and you'll see the thresholding of our both index. And you can see we have, this multiple missed a lot of water. And the reason is that a lot of the water bodies in India, they have vegetation. So the NDVI will not be less than 0. It'll be 0.1, 0.2. So you need to adjust this a bit. And I would say NDVI less than 0.2 is fine. I want to have the probability of having some water bodies having vegetation. A lot of the European or Western reservoirs, you can use 0 and it'll still work. There's a question on how do we learn about these indices and is there a reference to check about it? In the module 2 beginning, I'm going to cover a presentation which highlights all the different methods of water detection that has a comprehensive resources and reference paper for each of those indices. So just wait a bit when we start the module 2, you'll see that references. It's part of the course material. I'm going to show it to you. And as you are working on it, I think just understanding different indices and the nuances will help you select what is appropriate for your project. And you can see you can now combine this two and figure out what makes sense for you. There are a lot of places where this comes in very handy, where you have multiple indices or multiple conditions, and you can implement your own hierarchical selection algorithm where you say, select all the pixels where band 4 is greater than this, and then, if this is less than this, do this. So you can implement this kind of thing using this Boolean and conditional operators. Question is two parts. First, how do we detect vegetation in water? And second part is, how do I compute the area of that? So detecting vegetation in water, I showed the script in the beginning of this. We detected algae in water. You can use similar technique to detect any vegetation within the water. I'm going to show the script next. So that's the method that you can detect vegetation in the water. Once you have those pixels, we'll cover the computation of area in our module 4. That requires you to understand map reduce and some advanced concept. So once we come there, you'll be able to compute area of any detected pixels. So you can say in this water body, show me the total water pixels, show me all the vegetation pixels, and so on. You can compute the area in hectares or square meters. So that's coming up. Second question I'll answer first. Here we have there's two bands, you can consider two bands. And what we're doing is band math. You can do the same thing in QGIS. You load an MNDWI image, you load an NDVI image, and do your raster calculator and have this formula, right? So it kind of the same concept. It's just band math that you're doing that. They can be part of the same image, and you can do the band math, or they can be separate images. You can do that. So that kind of the similar concept here. There's another question on how to create the fundamental framework from a script. How do I think about implementing my algorithm? Well, this is the goal of the course, where we'll take different problem in each module and say, how do we go about solving them? And what are the steps? So once you get familiar with how Earth Engine is structured and how to solve different problems, you'll have a much clearer idea. The overall step would be select the data set, select the date range, get to your image, then figure out what algorithm you want to use, and then you can implement that. But again, once you see this in the context of different problems, you'll get much clearer idea. So as I said, be patient. I think as we progress, you'll have much clearer idea of how to implement your problem. There's a question around tile limit exceeded. Sometimes just running the script again fixes that error. So if you just run it again, it should go away. In case it kind of sticks it, we'll take a look at most likely it should just go away once you run it again. All right, let's try our exercise. Vigna, you can explain.